I am Jawaharlal, lecturer in electrical engineering. In previous section, I have discussed about the armature reaction, that is what is armature reaction. Today, I am going to discuss about the methods of reducing armature reaction. Please subscribe and like my channel for the next video. Now here we discuss the first is to reduce the armature reaction, we use the high reluctance pole tips. By the high reluctance pole tips, we can reduce the armature reaction. If the reluctance of the pole tips is increased, then the magnitude of armature cross flux is reduced and the distortion of the resultant flux density wave is minimized. The reluctance of the pole tips can be increased by using chamfered or eccentric pole shoes. A machine fitted with chamfered or eccentric pole face has short air gap length at the pole center and longer air gap length under the pole tips. That is, the profile of the pole shoe is not concentric with the armature core as shown in figure A. Here is the figure A. You should see here that this is the chamfered pole. How can you make the chamfered pole face? Now, some iron pieces we fitted at the pole center. Then there is a short air gap length between the pole face and armature core at the pole center, and the long here it is the pole tips and it is also the pole tips. So the long air gap here is between the pole face and the armature core at pole tips. So by chamfering the pole faces, we get the longer air gap at the pole tips and shorter air gap at the pole center. That's why we increase the reluctance of the pole tips. So the armature cross flux is reduced. Now, another method of increasing the reluctance to cross flux is to assemble alternately the pole laminations depicted in figure B. That is, this is the figure B. Now, this is the figure B. This is the figure B. You see what we say. I say that is, if the first lamination has the pole tips to the left, the second lamination has its pole tip to the right, the third lamination pole tip to the left, and so on, until the required pole depth is developed. Since the iron area under the pole tips is almost halved, the reluctance under the pole tips is considerably increased. Now here you see, first we laminate here the pole tips to the left, second is to the right. So one to the left, then right, then left, then right, then left, and then right. So you laminate first the left, second the right, third left, fourth the right, fifth left, sixth the right, and so on. That's why we increased the reluctance of the pole tips. That's why we reduce the armature reaction. See here. Now the another is the strong main field flux. During the design of DC machine, it should be ensured that the main field MMF is sufficiently strong in comparison with full load armature MMF. Greater the ratio of main field MMF to full load armature MMF, less is the distortion produced by the armature cross flux, and predominant would be the control of field MMF over the air gap flux. The next is by using the interpoles. Interpoles. The effect of armature reaction in the interpolar zone can be overcome by interpoles placed exactly between the main poles. The magnetic axis of interpole winding is in line with the quadrature axis. Interpole winding is connected in series with the armature so that interpole MMF is able to neutralize the effect of armature MMF in the interpolar zone at all levels of load current not exceeding the safe limit. So, this is the method we use. Again, we use the compensating winding. The effect of armature reaction under the pole shoes can be limited by using compensating winding. This winding is embedded in slots cut in the pole faces of a DC machines. Compensating windings are connected in series with the armature so that they can adjust their MMF in accordance with armature MMF. The winding is made in such a way that the flux produced by the compensating winding is in opposite direction to the armature flux with an equal magnitude of the MMF as that armature flux MMF. Therefore, it neutralizes the armature conductor's flux responsible for cross-magnetizing effect. This is the best but the expensive method. So, in compensating winding, we use the uh, uh, slot cut in the pole face. This is the main term you have to remember. Again, by shifting of brushes. We have seen that under load condition in the chapter of armature reaction, due to the effect of armature flux on the main flux, the distribution of air gap flux gets distorted. This causes to change in the magnetic axis, that is MNA, gets shifted by certain angle. Since the brush axis should lie along the magnetic neutral axis, but the change in the magnetic neutral axis, EMF is induced in the coil undergoing commutation, producing sparking at the brushes. In order to obtain sparkless commutation, the brush axis should also move along the magnetic neutral axis. So these are the methods which are used to remove the to reduce the effect of armature reaction in DC machines. Uh, for the next video, please like my video and also please subscribe my channel. That's why I send you good videos at your end. Thank you.